Hi guys, welcome to the first session of the ESP32 Playground series. The Playground series will have less theory and more of coding. So, without delaying, let us get started with motion detector using ESP32. This session will be divided into three main parts. First, creating the PI sensor component. Next, adding configurable variables to the PI sensor component. And finally, switching the bulb on and off based on the configured threshold. So before moving on, please subscribe to our channel so that you don't miss out any of our upcoming updates. Guys, we have a GitHub template available for the easy development. You guys can either clone this or fork this to fast track your development. So I have attached the link to this repo in the description. So let me go ahead and copy the URL. So let me clone the template repository. So we need to select the path. Let me quickly select the path in which I want to store this project. Open. So guys, though we have cloned the project, right, we need to open this in PlatformIO. So let us wait for the PlatformIO to get activated. If you see here, activating extensions, PlatformIO core installation. So let us wait for it to get installed. Yeah, it's done. So here, open the PIO home. Then open project, teachings, ESP32 playground, app. So we need to open this app folder because this is where we have platform ini file. So this is how the PlatformIO recognizes the project as a PIO project. So this is the template project. So if you see, we have a component created, which is a test component. So this is the source file. There's nothing much in it. And then we have the header file. So if we go here to the main src file, I have just included the template component. Now, if you see, if you normally create a project, right? So this has been .c. So we have to change it to .cpp and add extern block. So if you're not familiar about this extern block, please refer to my previous video on ESP32, getting started with ESP32 and PlatformIO. Now, if you see here, right, I have added certain comments over here. So what happens is there is a there is a guidelines provided by ESP-IDF team that the headers are to be organized in a certain way. So first we'll have the C++ headers followed by POSIX, then IDF headers, then component headers, public and private. So this AbIoTs test component is a private header, so I have added it here. So if we see the component, right, you can see here that stdio is a C++ header, so it needs to be here. And then we have the ESP log, which is IDF header, it's over here. So this is how it works. Now going back to the main file. Now though we have added this log d message, right, this will not be shown in the log. The reason being, we need to go to menu config, run the menu config, and change the log level to debug. By default, it will be in info. We need to go to component config. And by the way, you can also see the test component which we have created here, AbIoTs test component. I'll get to that at later point. In the part 2, I'll be explaining how to change this variable. So I'll not be explaining that in the part 1. Now let us go to log output. Default level is info. We'll change this to debug. And by the way, the second change which I'll be doing is optional. So I'll change the frequency of the ESP32. CPU frequency from 160 to 240 megahertz. This is optional, by the way. Now don't forget to save this. Now let me upload and monitor. Oh, there is an error. Cannot find the variable. Okay, the reason is if you find this error, right? So just run the menu config, then open the application manager, and here you can say get project version from kconfig. This is the, we need to enable this. So now let me save this and upload and monitor again. So guys, as you can see, the message was logged over here. So now let's create the ideal RTOS tasks. So for that, let me remove this. Okay, now let us import the RTOS libraries. So the first library which we'll be including is FreeRTOS, FreeRTOS.h, and the next library is task.h. So these are the two libraries we need for this project. Now, in order to create a task, we need to call the method xTaskCreate. Now, what are the parameters that are to be passed? So it needs the task function, name of the task, stack depth, parameters, priority, and the handle. So let me go back. So what I will do is I'll create a lambda. So auto, and I will call it as ideal task, and I need to pass the parameters. So let me log. So what in order to log, right, let me create a tag for logging. Const ideal task. So let me add a log here, ESP log D tag, booting the motion detector, and let me add a tag here, so the log would be starting the ideal task. So let me pass this ideal task over here. Now the next thing we need is name. So let me call this as ideal task. Next is the stack depth. So let me create one more constant over here. And let me call auto. And this should be my stack depth, which is equal to. So let me see if there is a minimum stack available. So we have config minimal stack size. So what I will do is this into 5. So this would be my stack depth. Stack depth. And next we need is parameters. For now, let me just pass null. So now let's go ahead and add the priority. So for this ideal task, I'll add the priority as 0. So an ideal task is a lowest priority task which runs when no other task is being executed. Okay. So greater the priority, like greater than this number, higher the priority. And also keep in mind that it's not something like you can give priority 1000, 10,000, something like that. I'll get into that priority, how to basically assign the priority in some later videos. But for now, for this ideal task, the priority is 0. Next is the handle. So for now, let me pass the handle as null. Okay, so this all seems good. But there's one more thing. So the ID, this lambda is there, right? Or whatever function we pass here, it should not return anything. So always keep in mind, whichever task you pass, whichever function, sorry, my bad, whichever function you pass, right? It should never return anything. So for that, let me create an infinite loop over here. So now this function will never return anything. It keeps on running until we actually kill the task. So now just for testing purpose, let me add a log inside the infinite loop. ESP log D. Let me pass the tag and ideal task running. So now if I do not give any delay, right, that will keep on printing the log at a very high speed, like whatever is this ticks speed. So now let me add a delay. So what I will do is, in order to add a delay, right, we need to use the method vtaskDelay. So this is the method which we need to use. But if you see what is the parameter type it expects is tick type. But we do not know like what is the tick. Okay, it will be different for different CPUs. The tick. Okay, now let me, what I will do is, okay, where was that? Yeah, here. So we have a method pdms to ticks. So what this does is, this will convert the time in milliseconds to the ticks. So I need a delay of 1 second. So 1000. Okay, so I have added a delay of 1 second. So remember this PDMS to ticks. If you give directly 1000, that will not be 1000 seconds or 1000 millisecond. It will be considered as 1000 ticks. So in order to convert from ticks to milliseconds, we need to use PDMS to ticks. So now let me align this, and now let me upload and monitor. So you can see the ideal task is running. So we can see the log getting printed every 1 second. So now let's go ahead and create the Pir Sensor component. So first let me rename these files, both the source and the header files, to Pir component. So right click, rename. Pir component. Rename Pir component. And also let's change the class name over here. So I'll refactor this to Pir component. So I'll select all the places where this is being used, apply. So everything is Pir component. So let's go to the source file. So this will be Pir component.hpp. And for now, let me just remove this. And here, let me remove this variables as well. This method. And let me make a plain constructor without any arguments being passed. Okay, so this seems all good. Now we also have to change the name in the CMake file. So this would be Pir component. And then again, one last file would be the config file. So this would be PIR component, and for now let me remove this variable, and this would be the end of PIR component menu. So all seems good now. So let us go to the source file, and again over here this name would be changed to PIR component.hpp. So let me just build this and see if it works properly. There is been an error. So okay, so what is the error? Cannot find the source file. So I think I have done some mistake. Yeah, so there is no toString. It's just plain constructor, and the spelling, there's a spelling mistake here. So that's a PR component. So let me build and see if it works. Now that the cleanup is done, let us begin with adding the business logic. So let us first add the GPIO headers. So let me go to the PR component, and here the first library we need is driver GPIO.h. We also need the library ESP-error.h. So now let us create the methods we need. The first method we need is a method to initialize the GPIO pins. So I'll make this as a private method. So the return type of this method would be RLT, and initialize, sorry, spelling mistake, initialize GPIO. This would take nothing as an void as an argument. Now we can actually make this function as a inline function. So let me next add a destructor. So we paste. So now we have a method to initialize the GPIO. We have the constructor and destructor. So now we need a method to start the motion detector. So let me create a method which returns ESP-IDF, and this would be start motion detector, and this again would take void as the parameter. There is no parameter to be passed. So the first method which we created is initialize the GPIO. To be precise, PIR GPIO pins. And the next method we created is start motion detector. Start the motion detection. So now let's head back to the source file and create the logic. Now actually let me remove this void. Yeah, so this is the constructor, and oh no, let me remove this. Yeah, so this is the constructor, and here let me add a log saying loading the motion detector. Sorry, my bad, I missed this. Yeah, so semicolon. So now let's write the method initialize GPIO. So PIR component initialize GPIO. So let me again add a log. Initializing the PR GPIO pins. So the first thing we need to create is we need to create a GPIO template. So if you are not familiar with GPIO templates or GPIO pins, you can refer to my video getting started with GPIO. So you can find the link to the video in the description. So the first thing we need to create is we need to create a template. So for that we need to use GPIO config t. So let me name this as PIR config and here. So let us define the parameters. The first parameter is the pin, the bit mask. So I will be using pin 2. So we need to use GPIO cell and my pin is 2. So the next parameter is the mode. So we'll be defining or we'll be using this pin as a input pin. So it will be GPIO mode input. The next thing is pull up and pull down. So we'll not be using any of those pull up or pull down. So we will be disabling them. So for that we need to use GPIO pull up, sorry, my bad, pull up disable. Then we'll disable the pull down, GPIO pull down disable, and finally we have the interrupt. So we will not be using again the interrupt as well. So we'll be disabling the interrupt. So interrupt disable. Now once we have defined the template, right, we need to pass this to GPIO config method. So let me pass the PIR config, and what we'll do is we'll actually return this. So okay, so the reason why we're returning whatever this method returns is, if you see, if we fail to initialize the GPIO, right, or the template, there's an issue with the template, or that pin is cannot be initialized in whichever mode we want to use, right, so this will throw error, and basically I will be just forwarding that error. So now let's create the logic for the start motion detector method. So the return type is ESP-IDF and PIR component start motion detector. So let me first add a log message. Let me call this, sorry, let me log starting the motion detector. Now after this, we need to initialize the GPIO method. So what we'll do is we'll actually capture this return type. So let me define a variable. So let me call this as operation state. And what I will do is I'll just return this. So I'll return the operation state. Operation state. So what we'll do is only if this operation state is a success or ESP okay, we'll start the RTOS task. So let me check if operation state equals to ESP okay. So only in this case we'll actually start the RTOS task. Let's start by creating a lambda function. So let's call this as auto PIR motion detector task. So first thing is we need to pass the parameters. So void parameters, and inside this there will be a infinite loop which will be running. Okay, and also let me add a log here. So ESP log D, and the tag would be motion task, and starting the motion detector RTOS task. And what we'll do is inside this for loop, right, we'll add a delay. So for the delay, we'll use vtask delay. So as we can see, we cannot access this method, right? So let me check if I have added the import. So let me go to the HPP header file. So as we can see, there's no RTOS header. So what I will do is let me add the RTOS header. So first thing is FreeRTOS, FreeRTOS.h. Then we need to add FreeRTOS task.h. So let me go back to the source now. So vtask delay. So I'll use PDMS to ticks. And for now, let me give a delay of 500 milliseconds. For now, I'll just print a message, say ESP log D motion task motion detector task running. So for now, I'll just add this log message. Later on, we'll have the business logic over here. So now that we have created the lambda function, let me go ahead and create the RTOS task. In order to create the RTOS task, we'll be using the method x task create. The first thing we'll pass is the lambda, which is PR motion detector task. Then we'll pass the name, which is motion detector task. Next, stack depth. So for the stack depth, I'll use minimum stack depth into 5. And then parameters. For now, the parameters are null. Then comes the priority. I'll give the priority of this task as 5. And next is the handle. So I'll pass null. So I have created my RTOS task, and there's an infinite loop. There is a delay. So everything seems good now. What I will do is I will run this task. So guys, if you see the message here, it's telling ideal task is running. But what about this task? The reason is we have not yet started, like we have not yet called that method from our main file. So if you see here, we have just added the PR library, but we have not called the start. So what I will do now is, let me create an object here, PIR component, PR component. And now what I will do is I will call PIR component start motion detector. So before my ideal task, I'm actually starting the motion detector. Now let me upload and monitor and see what is being displayed in the log. So if you see here, there's an error. Oh, the error is because, let me go back to the source file. Here we have not declared anything regarding the destructor. So let me add the destructor and I will say killing the motion detector. So let me now upload and monitor. Now if you see, right, the motion detector log is printed more compared to the ideal task. This is because the priority. So the motion detector task is of a higher priority than the ideal task. Now the final step in this PR component is reading the GPIO pin and deciding whether the motion was detected or not. So what I will do is I will create a variable integer motion detected state. Okay, and for this what I will do is I will do GPIO get level and I will pass the GPIO pin, which is GPIO number 2. So I'll get the state. Now what I will do now, once I get the state, right, let me write a conditional statement. If motion, there's a spelling mistake, so motion detected state, if motion detected state equal to high, then the motion was detected, else no motion detected. So let me remove this log, let me add it here and change this to motion detected, and here let me add no motion detected. Okay, 1 second, I'll just undo this. Yeah, motion detected, no motion detected. Now let me upload this. So guys, if you can see, motion is being detected, and if there's no motion, so no motion detected. So guys, this is the end of the part 1 of the motion detector using FreeRTOS and ESP-IDF. In the next part, we shall be using kconfig to create some custom variables for the PIR component, such as sensitivity and delay after motion detection. Also, we shall be connecting a AC bulb to the ESP32 using a solid state relay. So guys, please support us by subscribing to our channel. Jai Shri Ram.